Hello students. So in this video, we are going to discuss about the introduction to the transient and steady state behavior of an electrical circuit. So first let me see what is transient response of circuits. So in transient response in DC and AC circuits describes how voltages and currents change from one steady state to another when a disturbance such as switching occurs. So how the parameter changes takes place in an electrical circuit for a short period of time. This denotes a transient state. So transient state will be existing for a short period of time. Then the parameters will reach the steady state condition. So why this transient analysis is essential? It is an important concept for analyzing the real-time behavior of the electrical systems. So any type of electrical system, practically we'll be having some changes in voltages and current. So after the some period of time, the voltages and current will settle down to a constant value. So what is the time is being taken to reach the steady state value is very important in non-electrical circuit. So this is mainly occurring whenever switching operation takes place. Whenever there is a switching operation takes place in an electrical circuit, we are having a transient behavior. So the voltage and current changes will be there with respect to time. So this is mainly occurring because of energy exchange takes place in inductor and capacitor. So whenever this inductor and capacitor is capable of storing electrical energy, so during the transient period, so this will deliver the current. So the main cause of the transient state is because of this presence of the energy storage elements. So this transient behavior in non-electrical circuit, this dies out eventually after some time, then it will reach the steady state condition. Then let me see about what is a steady state condition. So steady state condition means the parameters does not change with respect to time. So that is a steady state condition. The voltages and currents in the circuit remains constant over the time, and all the energy storage elements like inductors and capacitors are fully settled. So fully settled means there will be no energy change takes place in the inductor and capacitor during the steady state period. So the steady state indicating that the voltage and current will reach the constant value with respect to time. So there will be no energy change occurring in the inductor and capacitor. So this will occur after a long period. I think the transient will be existing for some period. So it depends on the elements we are designing. So this transient period will be varying. So the transient period which is prolonging mainly depends on the nature of the elements. Depends on the nature of the elements. After that, it will reach a steady state condition. So if you take a DC circuit, so steady state condition is denoted by voltage and current will be constant with respect to time. I think but you will be having a constant current. So if you take a AC circuit, so the fixed amplitude and fixed frequency is denoting the steady state condition of the AC circuit. Okay, so in the AC circuits, the AC signal must have constant amplitude and constant frequency. So this condition will reach after the transient effect is completely died out. So next, let me see what is transient state. So already I told the transient behavior of the circuit is existing mainly depends on the energy storage elements. So while these elements are making an energy change, the transient behavior occurs in the circuit. So what is meant by transient state is the time period during which the circuit variables such as voltage and currents are changing. So this occurs immediately after a switching operation or change in input, which will continue until the circuit reaches the steady state condition. So transient state or transient behavior of the circuit denotes the current and voltage changes are occurring. So this will occurs for some period of time. After that, the voltage and current will becomes constant. It will reach the steady state condition. So next, let me see what is transient time. So transient time is before the circuit reaches the steady state condition, it is undergoing some transient behavior. So what is the time period is being taken from switch over from transient to the steady state condition, that denotes the transient time. So transient time is the duration required for the circuit to move from the transient state to the steady state condition. So the transient time, how much duration the transient behavior is existing, so it mainly depends on the circuit parameters. So if you design the circuit so that we can able to reduce this transient period. So transient period, the prolonging of the transient period is mainly depends on the design what we are making in the circuit elements, especially inductors and capacitors and resistors are making the doing the main part in uh, making this transient period. So next, let me discuss about what is natural and forced response. So natural response is also said to be transient response. So natural response is also said to be transient response. Forced response is said to be steady state response. So the natural response is mainly due to the energy already stored in the energy storage elements. So this natural response is mainly depends on the nature of the circuit elements, especially the energy storage elements such as inductors and capacitors. Depends on their interconnection and size, the natural response is defined. So this is also said to be source-free response or transient response. Then we are having forced response. So forced response is caused by the external sources. So mainly depends on the external excitation what we are providing to the circuit. So the complete response of the circuit is sum of natural response and forced response. So it is a sum of transient response and steady state response. So the cause for the transient behavior because of the energy storage elements. So the cause for the steady state behavior is because of the external input what we are providing for the circuit. So next, let me see Laplace transformation. So Laplace transform is a mathematical technique used to convert the time domain differential equations into algebraic equations in the S domain. So making it easier to analyze and solve the complex circuits. So while making the analysis in the electrical circuit, to solve the differential equations, we are using the Laplace transformation. This is mainly used to convert the time domain into S domain. Time domain into S domain. So that is the part of conversion we are doing in Laplace transformation. So next, let me discuss about what is the initial and final value theorem in Laplace transformation. So initial value theorem helps determine the value of the function at the beginning of time, while the final value theorem provides a steady state value of the function as the time approaches infinity. So to solve the differential equation to make the analysis in the circuit, so we are having some certain steps to follow. To solve a circuit using Laplace transformation, first we are converting the circuit which has been given. First, we are going to write the equation. We are going to form a differential equation. So through the Laplace transformation, we are converting the differential equation from time domain to S domain. So that we are applying some basic laws, nothing but basic Kirchhoff's voltage law. Then we are solving the equations using partial fraction method. Finally, we are converting this into inverse Laplace transform and inverse Laplace transform to get the final solution. So example for the transient circuit we are having RL transient. Now in RL circuit, when a DC voltage is applied, the circuit gradually increases from 0 to its final value following a exponential curve. The time constant is given by L divided by R, which determines how quickly the current reaches the steady state condition. So if you draw the transient behavior of your RL circuit, so this is the current waveform I of t with respect to t. So the initial value, so your final value will be V by R, initial value will be 0. So the final value is V by R. So final value we are getting V by R, initial value is 0. So if you are calculating the initial value of current for a RL circuit, initial value of current for the RL circuit will be 0. Final value of the current is nothing but V by R. So the time constant defined for the RL circuit is nothing but R by L. So time constant for RL transient circuit is defined as the 63.2% of its final value of steady state or final value or 36.8%, 36.8% of the initial value. So time constant is defined as the time taken for the current, nothing but 63.2% of its final value or 36.8% of its initial value. So the transient response occurs mainly due to the energy storage elements like inductors and capacitors. So in this inductor and capacitor, the voltage cannot change instantaneously, and the total response of any circuit is always the sum of natural and forced responses. So the cause for the natural response is nothing but because of energy storage element. Forced responses because of the external input what we are applying to the circuit. Thank you.